Section 3, Lecture 7. I explained consensus mechanisms. Lecture 8. I will now explain smart contracts. So, smart contracts, they are actually neither smart nor they are contracts, but they are typically programmatically executed transactions or PETs. What exactly does this mean? It's a transaction which is executed through a program. Now let's see further what a smart contract means. So typically speaking, smart contract is code plus a legal contract in a digital format. So basically a handshaking but digitally, so without the use of a third party. So let me take an example here before we proceed with the concept of smart contracts. If I want to buy a house or if I want to lease a house, say for maybe a year in a particular place, I would go and search for a broker. The broker would show me a list of houses and I would select one of them. Then I would pay a small fee to the broker and sign the agreement to move forward with the renting of the house. The seller and the buyer, as a buyer, I would pay some commission. Even the seller who wanted to sell the house will also pay some commission to this particular broker. So he is actually getting from two places. Now, if the entire information of all the sellers was listed on the blockchain and available online, all the buyers like me who want to buy a particular property or lease it out would go on to this, go online, search for the property, and now this is where the blockchain function would come in. So the information about a property is available online, like many sites are there which will give you the property. But when the information is available on the blockchain, I can log in and I can there can be a smart contract executed depending on the terms and the conditions between the buyer and the seller, where the third party is not involved. So let's go a little further and look at what would happen if the smart contract was not there. I would typically sit and bargain with that person to try to see whether I could haggle in a cheaper cost, while the seller on the other hand would try to be firm on his amount and say, I need this. And then in between the two, the broker would decide what should be the shifting, what should be the actual amount to be paid in this particular transaction. So if we were using a smart contract, the smart contract would be a computer protocol which would digitally facilitate, verify, or enforce the negotiation or the performance of a contract. So the negotiation or the finalizing of the contract can be done online. It allows the performance of a credible transaction without any third party. So if the information is available online and I put in the condition that if I have a price match with the seller, then we will agree for a contract, and the contract can be executed and digitally signed by both the parties. Now when both are signing together and the information is done online, the third party will be avoided. That's the advantage of a smart contract. Smart contract also enables transactions to be trackable and irreversible, because once a contract is executed, then it is always available and stored in the blockchain. Now what happens to a paper-based contract? It's possible that the paper-based contract could be lost or misused or even could be forged. And this can be avoided with the help of a blockchain. So smart contract basically is a code-based contract stored in the DLT or a blockchain, and it is executed autonomously. It contains embedded information about the ownership of the assets and the parties involved. That means the buyer and the seller in my example, and the amounts involved and on what condition both of them will sign the contract. The smart contract is also basically a multiple party signature which secures access to the contract. It is not open to all. So once I'm willing, I become a party to the contract, the seller also becomes a party, and then only the contract can be accessed, will be signed digitally by both, and then it is executed. So access to internal plus external data sources can trigger the execution of a smart contract. Now, to look further at what is the difference between a traditional contract and a smart contract. So typically speaking, as you can see here, if you look at the time, a traditional contract could take up to 1 to 3 days to be actually prepared. So physical preparation of the contract, ensuring that the legal terms are written correctly, then actually verification by the other party, then again finalizing it, and only then will be signed by both. A smart contract, it takes some time to program, but it can be executed in minutes. Remittance of payment in case of a traditional contract has to be done manually, while smart contracts, the moment this contract is signed, a trigger can be sent to the banking authorities to release the payment, so automatic remittance can be taken care of. Escrow is necessary in case of traditional contract, but in smart contract it's a part of the contract, so you don't require it externally. Traditional contracts become expensive because of the people involved and the way the documentation will have to be done, while in smart contracts it's hardly fraction of a cost. Physical signatures or a wet signature is required in case of a traditional contract, but virtual signatures can be from any place, anywhere. It's a digital signature which is required, which is quicker because the person may be anywhere in the world and he can still sign a digital contract. There's a need of a lawyer in case of a traditional contract because the legal terms have to be verified, while in case of a smart contract, lawyers may not be necessary. So after seeing the difference between the two, let's look at what are the challenges in implementing a smart contract. Smart contracts are good, blockchain is good, but still there will be a few challenges which need to be taken care of. For example, there's a need for one-to-one mapping of the computer, financial and legal arrangement from the physical to the digital framework. Now, if you do not relate the conditions properly, something can be missed out and smart contract execution may not be complete. Smart contract code requires robust testing and adequate controls so that we can mitigate any risks to the blockchain-based business process. It should not happen that when the selling was carried out, the amount is not correctly given or the tax is not included in it or some terminology is missed out. So robust testing becomes important because any controls which are there have to be mitigated because you have two parties which are signing. And if the signatures are involved, then that particular contract is going to be completed and accordingly the payments will be made. So that care has to be taken. A corrupted smart contract could paralyze the network because it's an automated payout and counterparties may be involved. They can swap the contract, so it will be extremely careful by ensuring that smart contracts are coded correctly and the correct operations are carried out. There may be some cyber risks when smart contracts, they may pick up data from external entities. So it is possible that any small risk may trigger the smart contract to execute, which should not happen. Hence, if you are using oracles or external entities data, then you have to be still more careful and ensure that cyber risks are also mitigated. So, if I just move back to the earlier part, we started with the definition of smart contracts, that is programmatically executed transactions or PETs. We looked at the basic definition and what exactly is a smart contract in terms of multiple party signatures involved, access to internal and external data sources which can trigger the smart contract. It is trackable and irreversible. Now, we also further saw the difference between traditional contracts and smart contracts and how smart contracts are faster and better and lawyers are not necessary. And then we saw the challenges in implementing smart contracts which have to be carefully mitigated so that smart contracts can reduce corruption, mistakes, errors and even third-party intermediaries. After looking at smart contracts here, we will move next into lecture 9 where we will talk about the components of a blockchain project ecosystem.